In this tutorial, we'll open TPDESIGN 5 software and create a new touch panel project. Let's start by going to the AMX website to download the software. There are currently two versions of software for configuring your panel: Touch Panel Design 4 for G4 series panels and Touch Panel Design 5 for the G5 series. Both versions of software function pretty similar, so whatever you learn on one version mostly applies to the other. For the purpose of this tutorial, we're going to use the MXT 701 G5 touch panel. On the panel's product page, look on the right side and scroll down until you see Application Files. That's where you'll find the appropriate touch panel design software version for that panel. Click on the link to download the software. After the file is finished downloading, launch it and follow the installation instructions. When the installation is complete, double-click on the TPDESIGN 5 icon to open the program. There are several different sections within the software to help you do certain tasks. The menu bar at the top allows you to access the software's advanced features and tools. The toolbar below is for quick access to more commonly used tools and can be customized by selecting View, Toolbar, and selecting which tools you want accessible in the toolbar. Tools can also be arranged in the toolbar by clicking and dragging on the left side of the tool item. The Design View window is the gray portion over here on the right. That's where we'll be doing the bulk of the panel's design and configuration. The Properties window allows us to adjust the properties of whatever item is selected in the Design View window. The status bar at the bottom lets us see helpful information like cursor position, size of the selected item, and master connection status. If you don't see these windows, you can go up to the View drop-down menu. Press any of the available windows to toggle the window on or off. I'm going to make sure the Workspace window, Properties window, and the State Manager window are all visible. Practice turning these windows on and off if you haven't already. To create a new panel design, click File, New. Enter a name for your project, and select the panel type. Click Next. Every touch panel needs at least one page, so give it a name. I'll call it Main. Choose the background and text colors, and a default font. Don't worry about committing to these settings. They can be changed later if you need to. Click Finished. Now that we've created a project, you'll see the Workspace window now has some folders in it. The folders contain the various design elements that make up the overall touch panel design. In the Pages folder, you'll see the page you just created. Pages cover the full screen of the panel, and only one page can be shown at a time. You can switch to different pages at runtime, and you can even use various hide and show effects like the current page fades away and a new page flies in from off-screen. Think of pages as containers for all other design elements like buttons and pop-up pages. The Popup Pages folder shows a list of pop-ups that can be shown on a page. Pop-ups are used for many things like a warning message, lighting and temperature controls, or countdown timers. We'll discuss pop-ups in more detail later. Subpages are a special kind of pop-up page that are used primarily for creating scrolling lists or sub-navigation. The last one here is only found on G5 series panels, application windows. These are used with embedded applications like Web Browser, Calendar, Contact List, and File Explorer. These applications can be run either full screen or in a window. So now that we know a little bit about getting around in touch panel design, we can move on to the next tutorial, Pages. Now that we have a project open, let's look at Pages in a little more detail. As I said before, every touch panel project needs to have at least one page. A page covers the entire screen area and is a container for all other graphical elements of your touch panel design. When we ran through the new project wizard, your first page was automatically created for you. It's called Main. Double-click on the page name in the Workspace window to open it in the Design View window. Now that we have a page open, you can see that there are now editable properties in the Panel Properties window. In the General tab, we can change the page name and add a description. We can edit address ports and codes, as well as channel ports and codes, in the Programming tab. These numbers are used to interact with the code running on a Netlink master. We'll talk more about these settings in a later tutorial. If I select the States tab, you can see that a page has only one state, off. Under the off state, there are various settings for adjusting the fill, text, bitmap, and video parameters. Let's add a background image to this page. To add an image, you need to have a few things set up first. Of course, you'll need an image. To make things easier, choose an image that is the same resolution as the page size. In this case, it's 1024 by 600. We can find that either by looking here in the status bar or by selecting File, Project Properties, Panel Setup Information. A number of different image file types are supported, but the most common are bitmap, JPEG, and PNG. Once you have an image, you'll need to add it to the Resource Manager. This is a repository for all external touch panel design elements like images and sounds. To add your image to the Resource Manager, go to Panel in the menu bar and select Resource Manager. Select the Image tab and then click Import at the top. Browse to your image location on your hard drive, select the image, and click Open. The image will now be placed in the Resource Manager and can be used on any page, pop-up, or button. Now that the image is in the Resource Manager, we can close this window. If we look back at the States tab, you'll see a line that says Bitmaps. Click on the line and you'll see a square button with 3 dots on it. Click on the button to select a bitmap for this page. Click on Add to open the Resource Manager and select the image we just imported. Click OK. You can change the justification of the image on the page here. Click OK to close this dialog. And there's our page. I chose an image that provides a full screen template to put the rest of my panel graphics in, but you can choose any graphic you like. If we create multiple pages on our touch panel, we can quickly change the look or activity focus of the entire user interface. Page flips can be done on the panel itself or through code running on the Netlink master. Let's say I wanted to add a full screen video preview window. The easiest way to do this would be to add another page by selecting Panel in the menu bar and selecting Add Page. This window should look familiar. Give the page a name like Video Preview and change the background color to black. Click OK and the new page shows up on our workspace and is open in the Design View window for editing. This time in the off state of the page, instead of selecting a bitmap, I'll select Video Fill. You can either select to use the MXA MPL breakout box or a streaming video feed. Let's use the MXA MPL. After you select the MPL, the page is now filled with SMPTE color bars. This is just a placeholder to let us know that it's a video and not an image. So that's it. We now have 2 pages to use in our project. Now that we have a basic understanding of pages, let's add some buttons in the next tutorial. Our page doesn't really do anything unless we add some buttons to it. Graphically speaking, a button is pretty much any design element that's not a page or a pop-up. Buttons can be, as the name implies, a simulated button that the user pushes to execute some type of command, like making a Blu-ray player eject the disc. They can be a bar graph that shows the current audio zone volume, lighting level, or outside temperature. They can also be static, non-interactive elements, like a company logo or a shadow effect. Since buttons cover such a broad range of uses, we'll be coming back to buttons several times throughout this training course. Back on our main page, we'll add a generic button by clicking on Edit in the menu bar and selecting the Button Draw tool. The mouse cursor changes to a pencil with crosshairs whenever you hover over an area where a button can be drawn. Draw a button by clicking and dragging on the page until the box is approximately the size you want. When you let go of the mouse button, there should now be a colored rectangle with small red squares surrounding it. That's our button. You can click anywhere on the button and drag it around the page, or click and drag on one of the little red squares to change its shape and size. In the Properties window, you'll see a few more options than we did on the pages we made. In the General tab, you can select the type of button you want it to be. Click on the drop-down to see the different types of buttons there are. Let's just focus on the most common types for now. General buttons are the most used type. They have two states, on or off, and these states are typically used for some type of feedback, like showing the on state to make the button light up whenever a particular source is selected, and the off state when the source is not selected. Multi-state general buttons have up to 256 states and are generally used for animations or giving several different types of feedback information, like stop, caution, and go. Bar graph represents a range of values and use the on and off state parameters to fill the button according to its current level value. Multi-state bar graphs can also have up to 256 states and are generally used for animation as well, such as a graphical representation of a fader on a mixing console. We'll stick with general for now. You can also give your button a name here. Don't forget to lock it unless you want this name to be overwritten if you change the button text later. The size and location of the button can be fine-tuned by directly entering values here. I'll make my button 173 pixels wide and 93 pixels high. The touch style refers to how you want the button to respond to touch. Active touch means that only the active pixels of the button will count as a touch. If I add a bitmap to this button or use a rounded border type, the transparent part of the button will not count as a touch if you press there. Bounding box means that, regardless of what part of the button has active pixels, everything within the rectangular outline of the button counts as a touch if you press there. Pass-through disables touch on this button entirely. This would be used for buttons that are non-interactive graphical elements. I'll keep the button set to active touch. Border style allows you to apply one of several predefined border types. It isn't necessarily required to have images created for every button on your touch panel. A lot of times, a simple button with a border is all you need. I'm going to add a border to my button. How about circle 45? That will give the button rounded corners with a 45 pixel radius. You'll see that the border color is different than the fill color. We'll change that later. If I disable or hide a button, I can keep them in my layout as a placeholder, but at runtime the functionality of that button will be disabled, or the button will be hidden altogether. The Button Programming tab defines how the button itself interacts with the code running on the Netlink master. There are three types of addresses used for buttons: address, channel, and level. We're going to be covering this programming tab in much greater detail in a future tutorial. Moving to the States tab, we can see there's a lot going on here. Don't worry, it's pretty much the same stuff, just separated for the different button states. Since this is a general button, there are two states, off and on. We can set the border color, fill color, text, and bitmap separately for each state. If there's anything we want to be the same for both states, just edit those parameters in the All States section so you don't have to make changes in more than one place. The current button colors don't go with my background image very well, so I'm going to change them. In the All States tab, I'll set my border color to something neutral, but makes the button stand out from the background. Click on the square with the three dots on it to open up the Colors dialog box. You can enter all of the color information manually if you like, but I'm going to select Color Name in the Choose Color By dropdown. Scroll down to the grays, and pick Gray 5. You can do the same thing for the fill color too, but you'll probably want different colors for the on and off states of the button. Under the off state, click on the Fill Color box. Select Color Name in the dropdown, and pick a color that goes with the background image on your page. When you pick a color for your on state, remember that it is intended to attract your attention, so we'd typically use a brighter color. To see the different button states in your layout, you can choose the state you want to see by clicking on Button in the menu bar and selecting Choose a Display State. There's a handy keyboard shortcut for that as well. F11 shows the on state, and Shift F11 will show the off. If you're not sure what state you're looking at, you can always enable the Function and State Overlay by selecting View in the menu bar and clicking on Display Function and State Overlay. The current state is shown here in the top right corner. This will also show the address, channel, and level codes. This button's looking pretty good, but what is it for? We need to add some text. I want the text to be the same for both the on and off states, so I'll edit that under All States. Choose the font for the text in the drop-down here. I like Helvetica, so I'll pick that. Enter a font size here, and edit the text by clicking on the box. I'll call my button System Power. Click OK when you're done. So now that we have general buttons down, in the next tutorial, we'll make a simple bar graph. To make a bar graph, start by selecting the button Draw tool and draw a rectangle like this. Now this time, in the General States tab, we'll select Bar Graph as the button type. Once I do that, we'll now see the off-state color on the top and the on-state color on the bottom. The bar graph will use these colors in different proportions to represent the current level value. The way I drew my bar graph, I want the bar graph to fill from left to right, not bottom to top. I can change that by selecting Value Direction and making it horizontal. In the States tab, we'll use a rounded border for all states. I'll use Circle 35 this time, and change its color to something that makes it stand out from the background. Just like the general button we made in the previous tutorial, we'll edit our fill color separately for the on and off states. In my case, I want my off-state color to blend into this graphic a bit, and my on-state will be a dark aqua to keep consistent with my color scheme. Looking good. Now I'll move to the Programming tab. Notice something different? Since this is a bar graph, there's now a place to enter a level port in code. We'll get into levels much later, so I'm going to leave the level port and level code fields alone for right now. The level function refers to how the bar graph responds to touch. Display Only can only be changed through Netlink's code and ignores touch. Drag changes the value of the bar graph as you slide your finger across it. Active will change the value as you slide your finger across it too, but also instantly jumps to wherever you put your finger. If you select centering for either one, the bar graph returns to the midpoint value when you lift your finger. Since this bar graph is going to be used for volume control, let's set it to drag. If we make it active, then the volume could accidentally jump to a really high level and blow the speakers. Active would be best used for lights, shades, or temperature settings, since having them jump to a high setting wouldn't typically hurt anything. I can also specify a range for this level. This will be the actual range that will be used with your code, and it's best to make it match the range of whatever you're controlling and avoid having to do fancy math conversions, since the default is 0 to 255. If this was a volume control on something like a DSP, I might use -80 for the low and 12 for the high. Let's use it as a percentage, so in that case the range would be 0 for the range low and 100 for the range high. So there's your basic bar graph. If we want to be really slick, we can add some text to it that will show what the current value is. To do this, let's go back to the States tab. Select All States and change the font and size. To keep consistent, I'm going to use Helvetica again with a 16-point size. Now when we go to enter text, there are special formatting codes we can use to show the current level value in its raw state or as a percentage. To find these formatting codes, click on Help in the menu bar and then click Contents. On the left side of this window, select the Index tab and type Formatting in the search window. You should see a list of some available formatting codes. Since our bar graph is already a range of 0 to 100, we can use either $V or $P. If our range was something else like -80 to +12, then $P will automatically convert the raw value into a percentage. Going back to the text field of our bar graph, I'm going to type volume $P %, and hit Enter. Now my bar graph on the page says volume 50%. And during runtime, this value will change whenever the bar graph's value changes, and I didn't have to write any Netlink code to do it. Now you know how to make a bar graph. In the next tutorial, we'll add some pop-up pages to our panel design. Now that we have pages and buttons under our belt, we can add a bit more flexibility to our panel design by adding pop-up pages. Pop-up pages work a lot like an OS prompt window on your computer, or a web browser pop-up page congratulating you on being the 1 millionth visitor and to claim your free iPad. Creating a pop-up page is kind of a mix of creating a page and a button. I can either click on Panel in the menu bar and select Add Pop-up Page, give the page a name, tell it how far in from the left and down from the top to be positioned, and enter the width and height. Or I can just draw the pop-up page like a button. Click Edit in the menu bar and select Pop-up Draw Tool. When we hover the mouse over the page, I can see the cursor change like it did with the button Draw tool, but this time there's a little blue page icon as well. Now to draw my pop-up page, I just click and drag on the page just like drawing a button, like this. Click Edit in the menu bar again and click on Selection Tool. Now we can drag the pop-up around and resize it just like we did with a button. We're going to use this pop-up for selecting the sources we'll be programming in the other tutorials, so put it across the bottom of the page like this. Going to the General tab in the Properties pane, I can give this pop-up page a name. I'm going to call this Sources. I can also see the current size and location information here and modify it if I need to do some fine-tuning. I can set a timeout for the pop-up here. This means that after the pop-up shows on screen, it will automatically go away after the amount of time I put here. I don't want this pop-up page to go away, so I'll leave the 0 here and the pop-up will never time out. To make this more visually appealing, we can add show and hide effects. Select an effect from the drop-down. I'm going to choose Slide Up from Bottom. Now there are boxes where I can tell it where to slide in from and how long it will take to slide in. Let's have it slide up from the bottom of the screen. The effect time is in seconds, so let's set that to 2 and do the same for the hide effect parameters. Going over to the States tab, you can see, like a page, there's only one state. Let's set the border type in color. Since my page's background image already has a bottom bar graphic, I really don't need any border or fill for my pop-up. So my border name will be None, and my fill color will be transparent. After we click here to open the Colors dialog window, there are two ways you can set the fill to transparent. Click here and slide this fader all the way to the left to set the opacity to 0, or click Choose Color By, Color Name, and select Transparent here. Now all you need to do is add some buttons. Just draw one for now. You'll be adding more buttons later. Set the border and fill properties to make the button fit with the rest of your theme. In all states, I'll round the corners of the button with the Circle 15 border and use a dark gray gradient fill for the off state and a blue fill for on. In the off state fill type, select top to bottom. Now you can select the gradient colors by clicking here to open the Fill Colors window. For the first color, click here to open the Colors window and pick the color you want to be on top. Click OK, and then do the same for color 2, but choose a slightly darker color this time. Setting the on-state fill should be easy for you now. I'm going with a light blue color. Set the button text in all states to Relays. I want this pop-up to always show when the touch panel first boots up. To do this, click File in the menu bar and click Project Properties. In this window, click Panel Setup Information. Right here is where you can tell the panel what page and pop-ups to show at Power Up. Click the green plus to add a pop-up and select the Sources pop-up. Click Apply and then close this window. As you can probably guess, the Relays button will need to launch another pop-up page. This new pop-up will be used in an upcoming tutorial and will have 4 buttons on it. First, let's make the pop-up. Click Panel in the menu bar and select Add Pop-up Page. We're making this page to control some relays, so we'll name it Relays. I want this pop-up to fill the center screen area, so I'll set the left and top position to 0 and 62, and the width and height to 1024 and 450. Set the page background color to transparent. We won't be needing a border, so set that to none, and then click OK. Because this is the first of many source pop-up pages that we'll be creating, I'm going to create a group name for my pop-up page right here. This allows me to group pop-ups with similar functionality and ensures that only one pop-up in this group can be on screen at a time. I'm going to enter the name Sources. After I hit Enter, you'll notice that there is a new subfolder in the Pop-up Pages folder. Any other source pop-up I create should also be put into this group by selecting the group name from the drop-down. Add 4 buttons to the pop-up. To make it quick, you can copy and paste the System Power button we drew in the previous tutorial. Select the main page and right-click on the button. Select Copy. Go back to the pop-up, right-click anywhere, and select Paste. Paste the button 3 more times. Change the All States text of these buttons to say, Screen Up, Screen Down, Screen Stop, and Screen Preset. When you're done, you can delete the original System Power button on the main page since we won't be using that for anything else. You can configure the Relays button in the source selection bar to show the Relays pop-up whenever it is pressed. This can be done with Netlink's code, but the panel can also do this by itself. Click on the button and select the Events tab. Page flips and activating pop-ups are done in the Button Release event. Click on Button Release and then on the square to show the Event Actions editor. Click the drop-down for Add Page Flip and select Show Pop-up. In the description over here, select the Relays page from the drop-down and then click OK. What we have to do now is transfer the file to the panel and verify that everything's working properly in the next tutorial. Okay, we've come a long way. Now that we have some pages, buttons, and pop-ups in our design, it's time to see it working on the panel itself. If you wanted to, you can save the TP file to a USB stick, plug it into the touch panel, and directly load it from there. But what if the touch panel is in a room across campus and you're not wearing your running shoes? To load the panel directly from TPDESIGN, the touch panel needs to be connected to a master. Now we can connect TPDESIGN to that master by going to Transfer in the menu bar and selecting Connect. In the Connect dialog, there is a drop-down that will have any masters you've previously connected to in it. Since this is our first time, click on New. In the window that just popped up, give your master a name. This will be added to the Recent Connections drop-down, so make it something easily identifiable like Classroom 108 or CEO Conference Room. I'll call mine Training Master. Select the transport type. You're always going to select TCP/IP here, not just because your computer most likely doesn't have a serial port, but because it's way faster anyways. Enter the IP address or URL of the master and make sure the port number is 1319 to use the AMX ICSP protocol port. If you're connecting to a master with ICSP security enabled, then you're going to need to check this box and enter the username and password here. Click OK. Your new connection is automatically selected, so just click here to connect to the master. You'll know TPDESIGN is currently connected to a master if you look right here in the status bar. Now click Transfer again, but this time select Send to Panel. In this new window, you should see a list of any connected panels that are compatible with this touch panel project. Select the panel you want to load the project to, Select Smart Transfer if you've already loaded a previous version of the file and all you did was modify something. This will only load the changes you made and is faster. Since this is a new project and the first time loading it, I'm going to select Normal Transfer. I'd also select this if the touch panel had a different layout entirely and I'm changing it over to this one. Click Send to start the file transfer. A transfer status window will appear below the Design View window and show you the real-time transfer status. The transfer progress is also shown on the touch panel itself, too. Once complete, the panel will take a few moments to launch the new project, and then it's ready to go. You should now have the basics of touch panel creation down cold, but just to be sure, we'll be adding to this touch panel file with each exercise throughout this course.
This tutorial will provide you with a brief overview of Netlink Studio. Netlink Studio was designed to make it easier to integrate, program, organize, and support all your AMX system programming needs utilizing the Netlink's architecture. We'll begin by checking the AMX.com website to ensure we are running the latest version that is currently available. From the home page, click on Products. If you scroll all the way down to the bottom of the page, you'll see a section called Integration Software. Click on Development Tools. Here is some of the software tools available for you to download. We're going to select Netlink Studio. On the right-hand side of the screen, under Application Files, we're going to select Netlink Studio. Notice that the software version number is displayed along with the size of the download. Once you select the license agreement, the software will begin downloading. After the download is complete, unzip and install the Netlink Studio software. Feel free to pause this tutorial while you complete the software installation. Okay, now that the software is installed, let's launch Netlink Studio. If this is your first time opening up the software, you'll see a What's New dialog box that will highlight any new features that have been added in the different software versions. I'm going to select Don't Show Me This Again and then close this window. Should you wish to review this information again, you could go up to the Help menu and select What's New. So let's take a closer look at how this software application is laid out. Starting at the top of the screen is the menu bar. I'm sure this is very familiar to Windows users. The File menu deals with file operations like opening, saving, and closing certain files. The Edit menu includes standard editing commands like copy and paste. Some other options, like search and bookmarking, will appear in this menu when a file is actually open. The View menu has to do with the different windows that appear on your screen, as well as which toolbars you wish to be visible. We'll talk about these different windows in a couple minutes. Next is the Project menu. Everything in this menu deals with the specific project you are working on. Things like the workspace, project, and system can be manipulated here. You'll learn more about this in a later tutorial. The Build menu has to do with compiling the code that you'll be writing. Once again, we have an entire tutorial that will be focused specifically on compiling your code. For the purpose of this tutorial, I just want to expose you to each of the different menu options. The next two menus are the Diagnostics and Debug menus. Both of these menus are useful in troubleshooting the code you have written. These are more advanced topics that will be touched upon a bit later in this course. The Tools menu is one of the most used menus. There's quite a bit of useful stuff in here. First and foremost, this is where you'll go to transfer your code, firmware, or other files into your AMX hardware. Also available are some basic functions like setting your master controller's date and time, or rebooting your master. At the bottom of this menu, you can import or export hotkeys and preferences. As you become more familiar with the software, you'll find that you begin to customize the software to work best for you. You might change the color palette, or set up shortcut keys to do certain tasks. This import-export feature allows you to save all those customizations and take them with you. Next, we have the Settings menu. This is another frequently used menu. This is where you'll go to set up the communications settings so you can get connected to your AMX hardware. Also available in this menu is Customize and Preferences. I just finished talking about customizing the software to work for you. Well, this is where you can change all those things. You want to change a hotkey? You can find that under Customize. The Window menu is simply a way for you to manage all the different windows you may have open on your screen at any given time. And finally, the Help menu is exactly as the name implies. You can locate help documents about Netlink Studio, the keywords that you'll be using in your code, or the standard Netlink's API document, otherwise known as Snappy. Below the menu bar are the toolbars. Most of the options you find in the menus that we just looked through are available as a toolbar item. We can grab the handle of any of the available toolbars and move them around however you wish to arrange them. Should you wish to show or hide any of these toolbars, just go up to the View menu. The first item in the list is Toolbars. When you hover your mouse over it, the list of available toolbars appears just to the right. Select or deselect whichever toolbar you wish. Now, let's take a look at the main windows that you'll be working with on your screen. The software is broken up into 3 main window panes: the Workspace bar, the main editor window, and the output bar. Let's start with the Workspace bar. Notice the 4 tabs at the bottom of the Workspace bar. They are Workspace, Online Tree, IR Data, and Zero Config. If you're viewing the Workspace tab, you're shown a tree structure of your entire workspace. This will show all of the individual files that are associated with the different projects and systems. You'll learn more about setting up your workspace in the next tutorial. Next, the Online Tree tab simply displays a list of all the devices that are currently connected to the master Netlink Studio is communicating with in a tree structure. If you're using IR devices in your project, the IR Data tab is where you'll go to view a listing of all the IR files included in the project. And it provides detailed file properties and channel function information of a selected IR file. And finally, the Zero Config tab displays a listing of all AMX IP devices on the LAN to which the PC running Netlink Studio is connected. Moving on to the editor windows, this is where you will display, view, and edit code files. You can have multiple files open at any time, and each code file opens in a separate editor window. The output bar has several functions associated with it. Notice the tabs on the bottom of the bar. The first one being the Status tab. This is basically the tab that is used when you compile your code. The results of the compilation will be displayed, and you can easily see if you have any errors or warnings in your code. The next 2 tabs are Find in Files and Find IR Files. These tabs will display the results of a search that is initiated from the Tools menu. There you can see a Find in Files and Find IR Files options. When you perform these searches, the results will be displayed in this output bar. File Transfer Status is where you will see the results of when you transfer files to your hardware. Whether it be code, a touch panel file, or an IR file, the results of that transfer will be displayed here. The final 2 tabs are Notifications and Diagnostics. Once again, these are for troubleshooting your code, and we'll learn more about this in a later tutorial. The last thing I would like to point out in Netlink Studio is the Status bar. This bar is located at the bottom of the screen, and it has very useful information at quick glance. The first 2 items you see say Off and Off. If you hover your cursor over these, you will see they have to do with notification and diagnostic messages. Again, we'll talk more about those much later. Next is the Last Push Message notification. If enabled, this is extremely useful. You can quickly see a push message come into the system. For example, you can press a button on one of your touch panels and quickly see the device number, the port number, and the channel number of that particular button that was pushed. Immediately next to that is the master controller connection information. This is the connection method that is active. In other words, Netlink Studio is trying to connect to the hardware using the connection method that is listed here. If you wish to change the method of connecting, simply click on it and it'll open up the Communication Settings dialog box. You'll learn more about getting connected in another tutorial. But remember one thing, green is good. If this box is highlighted green, it means you are successfully connected to a system. In the next tutorial, we'll take it a step further and learn more about the Workspace Hierarchy. In this tutorial, we'll focus mainly on the workspace, specifically the Workspace Hierarchy. Simply, the workspace is nothing more than a container for all the necessary files that will be used in your project. Some of the files included in this workspace are source code files, user interface files, IR files, modules, and many more. When we talk about the hierarchy of a workspace, we're specifically referring to the workspace, the project, and the system. Let's start at the top, the workspace. Conceptually, you can think of a workspace as a single job or customer, which may contain multiple projects and systems related to this job. To help you understand this better, here's a workspace called ABCU Campus. This is just a fictitious university which makes for a great example of how to properly generate an easy-to-manage hierarchy. The next level down, we have projects. Within a workspace, you can have one or many different projects. You may have a project for the biomed building and a separate project for the library building. You're free to add as many projects to this workspace as you'd like. The biomed building might be rather large, so we break these projects down one more level, the system. Inside the biomed building, we might have a system installed inside the biomed lab on the first floor, and we might have a system installed in the biomed study hall located on the second floor. Just like projects, you can have as many systems as you wish. That right there is the basic workspace hierarchy. It will always go from top to bottom, workspace, project, then system. The last thing to show you is where all of our files are stored. Located inside each system, you'll see 6 default folders which are automatically generated by Netlink Studio anytime you add a new system to an existing workspace, or when you create a new workspace using the Workspace Wizard. In an upcoming tutorial, we'll actually build this exact workspace using the Workspace Wizard. The first folder is the source folder. The master source code file always goes in the source folder. While you can have multiple source code files in this folder, only one can ever be designated as the master file. It'll be designated with a capital M in its icon. Next up, we have the include folder, and this is where you'll place all of your include files, such as component includes for a module, or they could also be custom written include files. We'll learn more about include files much later in this course. Next, we have the module folder, and this folder, of course, contains not only modules you've written, but also any AMX generated modules you've downloaded or created using the driver design software. We have an entire lesson on modules a bit later on. Next, we have the UI or user interface folder. This folder will likely contain your touch panel design files. After we build our first workspace, we'll include the touch panel file that we just created in this folder. Going on down the list here, we have the IR folder. This is where you'll place your IR library files. And lastly, we have the Other folder, and I highly encourage all programmers to make use of this folder. It's a great resource location for quick access for any files that are relevant to this system, but are not code files that belong in one of the above folders. For example, you might include a device's communication protocol Word document, or the owner's manual for a projector, or even an IP addressing spreadsheet for the network devices in your system. The most important thing to remember is that the hierarchy will always go workspace, project, then system. Let's now take a look at the different file types you'll run into as we begin building our workspace.
In this video tutorial, we'll be exploring the various types of files that exist in the world of AMX, what their file extensions are, and how they are used. The AMX software suite utilizes many different types of files. Each of these files have their own file extension. Once you become familiar with the different file types and their extensions, it's easy to recognize which particular software package utilizes each file type. A control system typically uses several different types of files. The main file types that we will look at in this tutorial are AXW, APW, AXS, AXI, TKN, TKO, JAR, TP4, TP5, IRL, IRV, IRN, RPMX, and XDD. As we know, Netlink Studio is an application for programming and maintaining entire AMX control systems. Netlink Studio supports Netlink system programming, but further to that, it makes it easy to manage all of the files associated with an entire control system into one centralized location. So let's first look at the file types that are native to Netlink Studio. These are the following: AXW, APW, AXS, AXI, TKN, and TKO. As we have just learned in the previous tutorial, the APW file is created by Netlink Studio when the user builds a workspace. Remember, a Netlink Studio workspace contains projects, the projects contain systems, and the systems contain system files. These files are all displayed in a hierarchical tree-like structure in Netlink Studio. All of the files contained in this structure, and the APW file itself, where this structure is stored, can be exported as a zip file directly from Netlink Studio, with the extension AXW. The AXW file is essentially a repository for all files that are linked to the Netlink Studio workspace and allows for easy transport of all of these files. Now let's take a closer look at all the individual files that you might find in a workspace. Most importantly, the master source code file and all other source code files associated with the system are created with the AXS extension. Remember, only one source code file can be specified as the master source code file in each system. It is designated by the capital M in its icon. Should you decide to assign a different AXS file as the master source code, simply right-click on the file and select Set as Master. TKN files, sometimes referred to as token files, are created when the master source code is compiled. It contains the binary version of the source code and is what the master processor reads to execute the program. Include files are created with the AXI extension. These files are similar to source code files in that they contain written code to be compiled. Include files cannot be compiled as a standalone file. However, these files can be referenced within any source code file by using the include statement. If an include file is present in the include system file folder, and if they are referenced in the source code, they are compiled as if the code they contain was part of the master source code file. The ability to reuse code is a desirable goal in any software development environment. However, code reuse takes careful planning and organization. Netlink Studio provides tools such as functions and modules to promote reusability. Modules are essentially Netlink subprograms designed to be plugged into a main program. When compiled, a module file has the TKO file extension. This file is similar to a TKN file in that it contains the binary version of the module's source code and is what the master processor reads to execute the module. Next, we will discuss the file types that are linked to Netlink Studio but are not necessarily native to it, i.e. they may require some other software for the files to be created. Caffe Duet is an extension of the Netlink's language for programming AMX control systems. Duet meets the challenges of an ever-changing control industry by expanding the capabilities of existing Netlink systems using the Java programming language. program in the Netlink language, program in the Java language, or do a little of both within the same control system. Files that are created using Caffe Duet are called Duet module files and have the JAR file extension. AMX has a large library of pre-written module files to control many different AMX and third-party devices. These files are freely available from the AMX Trade website, and the majority of these module files are in fact JAR files. AMX Driver Design is a Windows-based software application that gives any AMX dealer, customer, or display manufacturer the tools to create display device drivers easily and quickly. The wizard-based software is simple to use and requires no specialized training. The driver design application creates XDD files, which can be used in both Netlinx and RPM systems. User interface files, or UI files, are for use by touch panels and provide the user interface that allows the end user to control the system. As there are two different generations of touch panels currently available from AMX, there are two different software packages used to create the UI files for these panels. UI files for the G4 range of panels are created using TPDESIGN 4. This program creates files with the TP4 file extension. TPDESIGN 5 is used for the G5 range of touch panels and creates files with the extension TP5. IRL, IRV, and IRN files are all created in the IREdit application and contain IR control data to operate IR-controlled system devices. IRL files are standard IR library files, and IRV files are IR files that are exported from the VP Express application, which is used for legacy AMX Viewpoint wireless touch panels. IRN files consist of a database of IR files, either the read-only AMX IR database or a user-defined database. Each database can consist of both IRL files and IRV files. The AMX website will give you access to a large database of these IR files. The vast majority of these will have the IRL file extension. RPMX files are created with RPM, Rapid Project Maker. RPM is a cloud-based configuration tool that allows AV technicians or IT professionals to easily configure an AMX system by using a step-by-step approach. RPM simplifies more than just the configuration. It is a comprehensive tool designed to help throughout the process from start to finish, delivering standardized out-of-the-box functionality without the need for custom programming. The user can configure the project, create a user interface, and generate step-by-step instructions on how to install the system. Projects are stored in the cloud on rpm.amx.com, allowing installers to access and manage them from anywhere. Completed RPMX files can then be downloaded from the cloud and then uploaded to the control system and its devices using a software program that is very similar to Netlink Studio, called RPM Loader, which is freely available for download from a link within RPM. So as you can see, there are many different types of files that exist in the world of AMX. However, thanks to Netlink Studio, it is now far easier to manage and maintain each of these file types for each of your control system projects.
In this short tutorial, we're going to create the workspace that we'll be using for the remainder of this course. Before we launch Netlink Studio, we need to create a folder someplace on our PC where we intend to store all the files we'll be creating throughout this course. I'll keep it simple and create a folder on my desktop called P1 Course Workspace. From now on, if we create any new files or download any modules, we'll make sure to save everything in this folder. In fact, you probably still have your touch panel file open in TPDESIGN 5. Go to File, Save As, and browse to the location of our new folder. Save that file in our newly created workspace folder and close down TPDESIGN. We're ready to begin building our workspace. Let's start by launching the Netlink Studio application. We're now going to create the workspace that we discussed in the Workspace Hierarchy tutorial. Within Studio, select the File option at the top of the screen, then choose New from the drop-down menu. From the choices shown here, select Workspace Wizard and click OK. The first required field is the name you want to assign to the workspace. Consequently, this will become the file name Studio uses to generate the .apw file, which, as we just learned, is essentially the framework which contains the names of all the projects and systems within the workspace, as well as links to all of the files that are part of the workspace. I'll name this workspace ABCU_campus. If you'd like to add some notes to the workspace, just click on the File Description tab at the bottom. Enter your notes and click OK. Please realize that the file description is completely optional. Since I'm following the best practice of using a descriptive name for my workspace, I won't add any additional information here. Now that we've named our workspace, click Next. Note here that Netlink Studio has generated a file called ABCU Campus and needs to know where you're going to store this file. This is exactly why we created our folder. Browse to the folder location and click Next. Now the wizard will ask for the name of the project. Since this project represents an entire building on the ABCU campus, I'll name the project Biomed Building. Feel free to add some information into the project description details if you wish. Now select Next. Here we're given the option to add a system to our project. Since Netlinx is the default setting here, I'll just click Next to add a Netlink system into the project. Since there's one Netlinx master in the Biomed Lab, the system I want to add to the project is the Biomed Lab system. And, once again, you're given the option to add information about the system. I'm not going to add anything right now. Click OK, then Next. We haven't talked about system numbers yet, so we're just going to leave this set to 0. Now, Netlink Studio would like to know how you intend to connect to your master. We're going to bypass this for now. We have an entire tutorial that deals specifically with getting connected to your master. Let's click Next once again. We're now given the option to create an empty code file which will become the master source code file. Therefore, let's select Create an AXS file using templates from the list here and choose Next. You're given the option to choose either the Netlink standard template or a custom template you've already generated. Since this is your first workspace, I'm going to assume you do not have any custom templates created yet, so we'll just stick with the default option. Click Next. Here we enter the name of what will become the master source code file for this project. Since this code will be running on the Biomed Lab master, I'll name it Lab Master Source and choose Next. Studio needs to know where you would like to store this code file. In most circumstances, this should be in the same directory that the workspace file is stored in, and that directory shows up here by default. Click Next. And that's it. We've completed the generation of our workspace. Just click Finish to view the workspace in the Workspace window. You'll also notice that Studio automatically opens the master source file for us so we can begin writing code. As you can see, the wizard does a great job guiding you through the process of creating a workspace. Congratulations, you're now ready to begin writing code and bringing files into your workspace.
In this tutorial, we will learn how to add various files to your workspace. There are a few different ways to add files to your workspace in Netlink Studio. In previous lessons, we already created a system in your workspace that contains subfolders for the various file types that make up your system. These subfolders are Source, Include, Module, User Interface, IR, and Other. The first way to add a file to your system is to add it directly to the subfolder. For example, to add a source code file, right-click on the Source subfolder and choose Add Existing Source File. You can then browse your PC for the file, or multiple files, and click Open. In this example, the source file is of a .axs file type. You will then be presented with the File Properties dialog box. If you selected multiple files, you will have the option to edit the file properties of each file. File properties include the identifier, file name and path, relative path, and other information and options relating to the selected file. You can edit the identifier name of a file to change how the file name appears in the workspace. This does not affect the actual file name or the path to its location. This process can be repeated to add more files to your system, such as user interface or IR files, by right-clicking on the relevant subfolder. Another way to add files of different types is to right-click on the system folder and choose Add Files to System. By default, Netlink Studio will be looking for a .axs source file type, so change this to match the file type you are looking for. The file will then be automatically added to the appropriate subfolder. Lastly, Netlink Studio supports a drag and drop option which allows you to drag files from Windows Explorer onto the system folder for inclusion in your workspace. So let's actually add some files to our workspace. Follow along because we are going to use these files throughout the remainder of this course. The first file we're going to add is the touch panel you created in earlier lessons. First off, make sure your touch panel file is located in the same folder as your workspace files. Now, simply right-click on the user interface folder, browse to the workspace folder if you're not already there, and select the touch panel file you wish to add. You should only see one. Click Open. I'm not going to change the identifier here, so I'm just going to click OK. Our touch panel file is now included in our workspace. Next up, we will need to add an additional source code file. Right now we have a source code file, the lab master source file. This source code file will be what we use throughout the course in lessons to teach you how to program. Periodically we are going to assign you exercises to complete on your own. Therefore, we need a source code file that will be used solely for the purpose of completing these exercises. At the conclusion of this course, you will turn in these exercises for evaluation in order to receive credit for this course. So let's right-click on the source folder and choose Add New Source File. It then asks if we wish to create the file from an existing template. Yes, we do. Click Next. Just like when we set up our workspace for the first time, it asks which template we wish to use. We don't have any user-defined templates, so let's choose Netlink's standard template and select Next. It now prompts us to name the program. Pay close attention. We want this file named P1_exercises_your first initial _your last name. There's no need to check the box here, so click Next when you are done. It then asks you for the location where you wish to save this new source code file. Just make sure it's in the workspace folder you set up and click Next. Congratulations! You just created a second source code file. It will now open up in the source code editor window, and you'll also notice it is now listed in the source folder. For now, just close that file. We'll let you know when you need to start writing code in that file.
Now that we understand how to add individual files to our system, let's learn how to add additional projects and systems into our workspace. Follow along with me so your workspace matches mine. As of right now, we have one project, the Biomed building, and inside that building we have one system located in the Biomed lab. But what if the university wants to add another system in the Biomed study hall? This new system is still located in the Biomed building, just on a different floor. To accomplish this, we could go up to the Project menu and select New System, or I prefer to right-click on the Biomed building project and select New System. For the identifier, I'll call this new system Biomed Study Hall System. I'll leave the system ID set to 0. I won't add any description information or change my communication settings. Click OK. As you can see, the new system has been created, along with all the necessary resource folders. I'll minimize this for right now. Next up, the university decides to add an AV distribution and control system in the main library on campus. No problem. This time, we'll add a new project to the ABCU campus workspace. I'll right-click on my workspace and select New Project. I'm going to call this new project Main Library because that is the building we're working in now. I'll leave all the details blank and I'll click OK. The new project is now created. However, there's currently no system in the main library. So, we need to go back and now add a system to the project. Once again, on the project, right-click and select New System. I'll call this system Library AV Distribution. I'll click OK when I'm done, and there we go. We now have another system. Now, I'm going to do one more thing. This is not necessarily needed, but for the benefit of our next tutorial, I'm going to add source code files to each of these new systems I just created. Right-click on the source folder and select Add New Source File. Yes, I'll create it from an existing template. Hit Next. I'll use the Netlink standard template. Next again. And I'll name my source code Library AV Source. Next. I'll save this source code in my workspace folder and hit Next. That's it. Hit Finish to add our code template. I'm now going to do the same for the Biomed Study Hall system. There's no need for me to step through it, so follow along. The name I'll use for this source file will be Study Hall Source. Perfect, we're done. Now, all three systems have the Netlink source code template in the source folder. I hope you can begin to see how easy it is to organize your workspace when you properly set up your projects and systems. In this course, we're only going to be working in the Biomed Lab system. Therefore, let's minimize all the other projects and systems so we don't get confused.
In this short tutorial, you'll learn how to compile your code in Netlink Studio. First of all, let's discuss what it means to compile or build your code. The process of compiling is necessary to transform the code you will create in the Netlink's programming language into binary machine code which can be run by the AMX Netlinx processors. Any errors must be corrected before the compiled code can be loaded into a processor. It is also strongly recommended that any warnings be resolved as well, although a warning will not stop your code from loading and executing. There are several options for compiling or building your code in Netlink Studio. You can build active system, build system, build workspace, build project, and build a specific source code file. Let's step through each one of these options. Here's our workspace. If your lab master source file is not open, double-click it and open it up. I highly encourage you to follow along because you are going to be compiling your code a lot throughout this course. The active system is the system you are currently working in and is highlighted in bold in your workspace. In this case, Biomed Lab system is the active system. To compile or build the code for this system, click Build on the menu bar and select Build Active System. Before we talk about the other methods of compiling, let's briefly examine the output bar. The first line indicates the Netlink's compile starting. Subsequent lines will indicate the source code location, the number of errors and/or warnings generated, how much memory the compiled code will require, and the number of token and variables present in the compiled code. If there are no warnings or errors, you are ready to load your code into the Netlink's processor. Since I have yet to write any code, the only thing that is being compiled is the Netlink's standard template, and of course I won't have any errors or warnings. Now let's see what happens when I deliberately place an error in the code. I'm going to write a bit of code in this Define Device section. Don't worry if this doesn't make sense at the moment. Defining devices will be covered in a future learning module. As it reads now, this statement is correct. However, if I remove the colon near the end of the statement, the syntax will be incorrect and will generate an error during the compile operation. Notice we now have an error listed indicating invalid syntax in the code. The error line shows the source code file with the error, the line of code with the errors indicated in parentheses, and the next line shows the error count. You can manually navigate to the error, or you can quickly move to the error by double-clicking the error line. Now that I have fixed the error, I will recompile the code to check my work. 0 errors and 0 warnings, just what we want to see. Now that you get the idea, make sure you delete that small line of code so it doesn't mess us up later on. Let's look at a few more compiling options. To build any system in the workspace, even if it is not the active system, simply highlight the system you wish to build and select Build XXX System from the Build menu, where XXX is the highlighted system, in this case, Biomed Study Hall System. Notice we get a pre-compiler error when we do this. It says, no master source code file is designated for the Biomed Study Hall system. Let's fix this. Select No. This error is occurring because we have not yet set this source code file as the master source code. Expand the system and source folders. Now, right-click on the source code and select Set as Master. Notice a capital M now appears in its icon. Remember, we can have multiple source code files in our system folder, but only one file can be associated or loaded to an individual system. Let's do the same thing for our main library project while we're here. Expand the folders and right-click on the library AV source file. Select Set as Master. Now that each system has a master source code file assigned, I'm going to minimize these folders once again. If you wish to build all of the systems within a given project, highlight the desired project and select Build YYY Project from the Build menu. In this example, Biomed Building is highlighted, and when Build Biomed Building is selected from the Build menu, the code for Biomed Lab System and Biomed Study Hall System both compile. To compile all of the code for the entire workspace, select Build Workspace from the Build menu. This will compile the code for all projects and systems within the workspace. In this case, this includes Biomed Building and Main Library. The last compile option is Compile on the Build menu. This may be used to compile an individual file within a system and is very useful when you are writing code and wish to do periodic checks for errors such as syntax that may have creeped into your code. This option will only work in the code currently being shown or worked on in the editor window. Also, you may wish to note that the standard hotkey for this function is F7, and that right-clicking inside the editor window will also present context-sensitive options for compiling the individual file or the active system. Another tool you may find useful is the Build toolbar. To use it, turn it on from the View menu and you will have all of the build functions available which we have discussed in this module. Finally, I want to discuss the various compiler preferences that are available. Go up to the Settings menu and select Preferences. The first item in this list is the Netlink compiler. I want to focus your attention on the first 3 items in the list. First, we have Compile with Debug Info. We are going to be debugging our code in a much later tutorial, but for now we want to make sure this is checked. Next, we have the option to build with source. This option, if checked, will include the source code file into the compiled package that will get sent to the Netlink controller. If this is selected, you will have the ability to extract the code out of a master. Then you also have the ability to password protect that source code with the third option. The decision to check or uncheck this feature is a business decision that only you can make. Do you want someone to be able to extract your code out of a Netlink master or not? I'll leave this unchecked for now. Hit OK to keep your changes. Now that we know how to compile our code, next we'll learn how to get connected to our master processors and transfer the code. In this next tutorial, we're going to discuss how to configure master communications settings. There are multiple ways to connect to a master, via an Ethernet network, via a serial connection to a PC, and via a USB connection to a PC. While Ethernet is the preferred connection method, serial and USB are useful when the IP address of the master is not known. Also, there are 2 types of master communications settings we are going to discuss: active system communication settings and default workspace communication settings. For now, we'll start with Active System Communications Settings. Access the Communication Settings dialog box by selecting Active System Communication Settings from the Settings menu. If the IP address of the master you wish to connect to is known, select the Network tab, then select New and enter the IP address. You may also enter the description if desired and the username and password if necessary. For purposes of this tutorial, we have not enabled security, so we will leave the username and password fields blank. Select OK. You now have a new entry in the connection listing. Now highlight the entry, click Select to apply this new connection as the current master connection. The connection is now shown in the black box at the top of the dialog as the current master connection. You can also double-click your entry to apply it as the current master connection. Once you have the desired connection displayed in the black box, select OK. Verify your connection by selecting the Online Tree tab in the Workspace bar, clicking the Display button, and selecting Refresh System Online Tree from the context-sensitive menu. Alternatively, you can right-click anywhere in the work area to access the context-sensitive menu. Once you have selected Refresh System Online Tree, the connection setting area in the status bar will highlight green if the connection is successful. Remember, green is good. You may be looking at the online tree thinking, what is all of this? Don't worry, the next tutorial will dive a bit deeper into understanding the online tree. For now, let's discuss how to connect to the master if you do not know the IP address. There are 3 ways you can connect and configure the settings. The first is also a network method. First, connect your PC to the same network as the master. Then, access the communication settings as before and select the Network tab. This time, click Listen for Masters, and when the master appears in the list, click Stop Listening and select Add. This will bring up the New TCP/IP Setting dialog box. Fill in any fields that are not already filled in as needed and click OK. Highlight the new entry, click Select and OK, and verify your connection as before by refreshing the online tree. Another method of connection is USB. This method will only work with the newer NX series master controllers which have USB connectivity. Connect a USB A to B cable from the USB B port on the master to a free USB A port on your PC. Access the communication settings and select the USB tab. The master should appear on the available USB connections list. Click Refresh if necessary. Click Edit to enter the username and password if required. At this point, you may click OK to complete and test the connection to the master via USB. The last method of connecting is serial. Note that this method will only work with the older generation NI series controllers, as the newer NX series do not have serial ports. First, connect a serial cable from the port on the master to the serial port on your PC. If your PC does not have a serial port, you will need to use a USB to serial adapter. Access the communication settings as before and select the Serial tab. Select the appropriate port and baud rate for this connection. The default baud rate is 38.4. Dip switch settings for configuring baud rate may be verified by clicking on Dip switch settings. Data bits, parity, stop bits, and flow control are 8, none, 1, and none respectively. Enter the username and password if required, then click OK and verify the connection as noted earlier. Now that we've covered configuring active system communication settings, let's discuss default workspace communication settings and the differences between the two. Active system communication settings apply only to a single system. Default workspace communication settings are the communication settings which Netlink Studio will use when there is no workspace open. Why is this useful? Well, I may wish to connect to a system to check to see if all devices are online, or perhaps set up a terminal or telnet session, or even transfer firmware. To access the default workspace communication settings, select Default Workspace Communication Settings from the Settings menu, then highlight and click Select on the desired default system for this empty workspace. Now that we've learned how to get connected to our masters, the next tutorial will cover details of the online tree. As promised, in this tutorial we're going to take some time to examine the various elements contained in the online tree. When you refresh the online tree, you are refreshing the online device listing for the system which has the master controller to which you are currently connected. The first line shows the system elements. You can also see the number of devices connected to the system and the IP address of the connected master. Subsequent lines show the various subdevices in the system and the current firmware version being used. For instance, an NX4200 master controller has two subdevices, 00000, which is the actual master controller itself, and 05001, which is the device controller. Another example would be an ANOVA DVX, which contains the same two subdevices as the NX4200, but also adds a third device, 05002, which is the switch device controller. Next, each subdevice may have subdevices of its own, each with its own firmware version. These are shown with red icons. You can click the plus sign next to a subdevice to see these additional subdevices. When you click the plus sign next to a device, you may also notice a list of ports shown in green. Ports are very important, and as you progress through this online class, you will learn more about ports. Further on in this class, you will also learn about dynamic and virtual devices. You can also check the online status of these devices as well as the version and port information. Lastly, there may be one or more device states folders listed at the end of the online tree. These folders categorize NDP or Network Detect Proxy devices according to their device state. Here is a list of the various possible device states. Click pause here to examine this list in depth, and click play when you are ready to continue. Another option for refreshing device states is to select Refresh Network Online Tree. This option allows you to not only refresh the device states for the master you are currently connected to, but also allows you to refresh everything in the entire network. Now that we've examined the various elements of the online tree, we'll move on to transferring our code to the master controller in the next tutorial. Now that we've learned how to set up communications with our master controller and have examined the online tree, in this next tutorial we're going to learn how to transfer files to the master. With the workspace open and the active system set to Biomed Lab System, select File Transfer from the Tools menu to bring up the File Transfer dialog box. You may also use the File Transfer button on the standard toolbar to do this. First, we'll need to add some files to the send list. There are several options to add files to the send list. Let's start with the quickest and easiest first. Click the Quick Load button to bring up the Quick Load dialog box. From the pull-down list, select whether you wish to load the entire workspace, the active system, or select a system from the list. In this case, we're only going to work with the Biomed Lab System, so we can select either the active system or specifically select the Biomed Lab System. Next, select the types of files you wish to include in the transfer. Since this is the first time we are loading this project, we will keep all of the file types selected. Click OK, then click Send to begin sending the files. It's that simple. Now, let's talk about some options you can employ for subsequent file transfers. Since we left the Remember Last Items Transferred box checked, you'll notice that the previous items we placed in the send list are still there. This may be unchecked if you don't wish to have transfer items remembered. In fact, we highly recommend that beginning programmers leave this box unchecked to avoid confusion, as it's good practice to select the files each time you wish to perform a transfer. For all future transfers, I will leave this box unchecked. You may also have noticed that each item in the list has a checkbox preceding it. One example of how this attribute is useful is if you wanted to load only the .tkn file to save time during testing. To prevent transfer of the .src file, uncheck it. Click Send to transfer only the .tkn file. There are also some file transfer preferences which may be set. Click Preferences to access the Preferences dialog box and view the list of options. Until you become more experienced as a programmer, it is recommended that you leave all of these options checked. There are 7 buttons which may be used to perform list operations. Save List allows a file list to be saved to your PC so that it may be recalled at a later time. Load List allows a saved list to be recalled. Up and down allow you to reorder the list on an individual file basis. The Add button allows you to add specific files from any project or system available in the Workspace from the Workspace tab, or individual files of any type from any location accessible to your PC. Remove allows individual files to be removed from the transfer list, and Remove All clears the transfer list. Most of these features are rarely used, but I just wanted to draw your attention to them in case you wish to use them. Lastly, the Edit button allows convenient access of the communication settings and device mapping functions. In the next section, we will begin to cover programming concepts.